Hello, good morning, children. Yesterday, you have learned about the definition of rational numbers. Now, today, we are going to see the next topic regarding the rational numbers. As you have know that regarding the integers and whole numbers, you have already learned those. They are nothing but properties of rational numbers. Now, see here, properties of rational numbers. You know that here we have learned already the properties regarding the integers and whole numbers. Once we recall them, so those properties only continue even for the rational numbers also. The first one is closure property. Second one is commutative property. Next, third one is associative property. Fourth one is distributive property. Next, identity and inverse. Whatever I teach you here, just you need enter into your notes and make the notes of all these the topics which are very important for your further classes too. Now, I am going to teach you about the closure property under addition and multiplication. First, in this closure property under addition, here I am taking any two rational numbers such as let a comma b are any two rational numbers such that a plus b is also a rational number then rational numbers when rational numbers satisfies closure property under addition. I once again repeat here, listen here. Let a comma b are any two rational numbers such that a plus b is also a rational number. Then rational number satisfies closure property under addition. Now, for this property, now we are going to see an example regarding the closure property under addition. Example, I'll consider let a is equal to minus 3 by 4, b is equal to 5 by 4. I'm taking here the like fractions, it's equal here for a and b. So, it makes the addition or subtraction to make it as easy and taking all this like fraction as the examples. Now, consider a plus b. Minus 3 by 4 plus 5 by 4 is equal to 4 is a like common here. So, minus 3 plus 5 is equal to 2 by 4. is also a rational number. Now, this is the example under addition. This is the example under addition. Now, we are going to see the one more example regarding multiplication. So, the definition here, just note down whatever I say here. Let a comma b or any two rational numbers such that a into b is also a rational number, then rational number satisfies closure property under multiplication. So once again I repeat here that let a comma b or any two rational numbers such that a into b is also a rational number, then rational number satisfies closure property under multiplication. So whatever I have given written on the board for the addition, just wherever the sum is there, change into multiplication. Now we are going to see the examples for multiplication of the closure property here. A into B. Now here I am changing here into. So 3 into 5, we have for the multiplication, we have to multiply the numerators as well also the denominators. 3 5s are 15, minus into plus minus, and we also multiply the denominators also. 4 into 4, 16. So minus 15 by 16 is also a rational number. Then now we can say that closure property satisfies the, then we can say the rational number satisfies the closure property under addition and multiplication. Now we are going to see another one more property here, commutative property. The B1 is the second one is the commutative property. Now I am going to define it. Let a comma b or any two rational numbers such that a plus b is equal to b plus a plus b is equal to b plus a, then rational numbers satisfies which property? Commutative property. Under addition. So once again I repeat here, for the commutative property, let a comma b are any two rational numbers such that a plus b is equal to b plus a, then rational numbers satisfies commutative property under addition. Now look at here, the same definition continues even for the multiplication also, where the plus symbol changes into here, and also here also into, and it changes to addition, change to multiplication. So once again I repeat the commutative property under multiplication. See here, let a comma b or any two rational numbers such that a into b is equal to b into a, then rational number satisfies commutative property under multiplication. Now we are going to look for the examples regarding the commutative property under addition and multiplication, children. I hope you are noting down all these points in order to make it perfection regarding the definitions here. Now, example. The same values we are going to take for the a and b here. Let a is equal to minus 3 by 4, b is equal to 5 by 4. Now the rule for the commutative property is that a plus b is equal to b plus a. So a minus 3 by 4 plus b 5 by 4 is equal to b 5 by 4 plus a plus of minus 3 by 4. Now make this addition of this. The LCM is 4 as it is here. Minus 3 plus 5 is the minus 3 plus 5 is equal to 5 plus into minus minus 5 minus 3 by 4 is equal to minus 3 plus 5. It becomes 2 by 4 and 5 minus 3 is equal to 2 by 4. 2 ones are 2 twos are 2 ones are 2 twos are. It becomes 1 by 2 is equal to 1 by 2. Now here we observe that commutative property satisfies the example here. Now we can say the rational number satisfies the commutative property under addition. Now we are going to see the example for the multiplication. So the rule is that a into b is equal to b into a. Now a, here we have minus 3 by 4 into b 5 by 4. Again the b 5 by 4 into a minus 3 by 4. So for the addition we are taking the LCM, but for the multiplication we have to multiply the numerators together and the denominators together. Now minus 3 into 5 is the minus 15 by 4 4s are 16. Again 5 3s are 15 plus into minus minus 15 by 16. Now we observe here that minus 15 by 16 is equal to minus 15 by 16. What we have observed here? Now these are rational numbers satisfies the commutative property under multiplication. So I think you understood the both the properties here for the closure property and commutative property under addition and multiplication. Now we are going to see the third property here. Third property is the associative property. Here now, up to now we have took only two values a comma b or any two rational numbers. Now we are for this associative property we are going to take three rational numbers. Let a comma b comma c or any three rational numbers such that a plus of b plus c is equal to a plus b plus c. This is the rule here. Our condition is that. So observe that a plus of b plus c is equal to a plus b plus c. Then rational numbers satisfies associative property under addition. So once again I repeat the rule here. Let a comma b comma c are any three rational numbers such that a plus of b plus c is equal a plus b plus c. Then rational number satisfies associative property under addition. So now if we go for the multiplication, for all the properties we are seeing under addition and also the multiplication. Now if you are going to see for the multiplication, change the addition symbols into multiplication symbols. Now addition change to multiplication. Let A comma B comma C are any three rational numbers such that A into B into C is equal to A into B into C. Then rational number satisfies associative property under multiplication. Now we just consider the examples regarding associative property, whether associative property satisfying the rational numbers or not. Just we now observe them. Example, let A is equal to minus 3 by 4, B is equal to 5 by 4, C is equal to 2 by 4. If you want to consider for any other examples also, you can try for other examples even by taking the ABC values for other numbers also. You can change the values and you can try for the other examples also. Then you can get the perfection in solving the rational numbers. So here the rule is that A plus of B plus C is equal to A plus B plus C. A here we have minus 3 by 4 plus B 5 by 4 plus 2 by 4 is equal to A plus B minus 3 by 4 plus 5 by 4 plus 2 by 4. Now consider here, first solve whatever is there in the bracket. Minus 3 by 4 plus 5 plus 2, 7 by 4 is equal to. Now here that we have in the bracket minus 3 plus 5. Minus 3 plus 5 will get as 2 by 4 plus 2 by 4. So minus 3 plus 7, as they are like fractions, we can add directly the numerator. Minus 3 plus 7 becomes the 4 by 4 is equal to 2 plus 2, 4 by 4. Nothing but 4 ones are 4 ones are 4 ones are 4 ones are. We'll get here, consider 1 is equal to 1. Now we observe here the rational numbers satisfies the associative property under addition. For the given values, you can change the values, we can alter the values and you can solve for the other examples also here. Now we are going to search for the multiplication. Whether rational numbers are satisfying the associative property under multiplication or not. Now we observe here, we'll replace the values for A comma B comma C. A is equal to minus 3 by 4 into B is equal to 5 by 4 into C 2 by 4 is equal to A minus 3 by 4 into B 5 by 4 into C 2 by 4. First what I said, have to solve whatever is there in the bracket at first. So minus 3 by 4 into 5 2s are 10 by 4 4s are 16. What I said for the multiplication, you should not take the LCM, you have to multiply both the numerators and also the even for the denominators. So minus into plus minus, 3 5s are 15, minus 15 by 16 into 2 by 4. So 3 10s are 30, minus 30 by 16 4s are, or 4 into 16, 16 4s are 64 is equal to 15 2s are 30 minus 30, 16 4s are 64. You can cancel out them and you can make into simple terms or you can leave here also. So now we observe that minus 30 by 64 is equal to minus 30 by 64. Now we observe that here the associative property is solved here. Now we can say that rational number satisfies the associative property, even addition and multiplication. Now we are going to see the next property, that is nothing but the distributive property here. The fourth one is the distributive property. So look at here, what is the condition regarding the distributive property? Children, I think you are getting recalled regarding all these properties, whatever that you have learned, even in 6th class and also in 7th class. Those properties only and those rules only getting repeated here. But instead of keeping the whole numbers and integers and giving the examples regarding the rational numbers, that's enough. So already you have learned all these properties regarding this in 6th and 7th. In what topics, regarding which number system, those regarding to first in 6th class whole numbers and in 7th class regarding integers. Now we are seeing about the distributive property. So now we are considering distributive property here. See the rule here. Let A comma B comma C or any three rational numbers such that the property here that A into B plus C is equal to A into B plus A into C. See the property A into B plus C is equal to A into B plus A into C. Then we can say that then rational numbers satisfies distributive property of addition over multiplication. See the rule here. Let A comma B comma C are any three rational numbers such that A into B plus C is equal to A into B plus A into C. Then rational number satisfies the distributive property of addition over multiplication. Here we are not we observe here. See that the addition and multiplication not different. Both are here itself. So what here the rule name itself indicate distributive. So the multiplication is distributed here B and C. Here the multiplication is distributed over addition. Now let us see the example regarding the distributive property. So example, again we take the same values for this. Let A is equal to minus 3 by 4, B is equal to 5 by 4, C is equal to 2 by 4. Now see the rule that A into B plus C is equal to A into B plus A into C. Replace the values here for the A, B, C. Minus 3 by 4 into B 5 by 4 plus 2 by 4 is equal to A minus 3 by 4 into B 5 by 4 plus again the A value minus 3 by 4 into C 2 by 4. So minus 3 by 4, first open the brackets. Here it is the addition and these are like fractions. Now as these are the like fractions, add only the numerators. 5 plus 2, 7 by 4 is equal to minus 3 into 5 minus 15 by 4 plus minus into plus minus 3 to the 6 minus 6 by 4. So 3 7s are 21 minus into plus minus 21 by 4 is equal to minus plus into minus 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 15 minus 6 minus 21 by 4. So look at here, we have got at last we got the values minus 21 by 4 is equal to minus 21 by 4. Now we observe that the distributive property is satisfied here. Now we can say that rational number satisfies the distributive property of addition over multiplication. So students, I think you understood the properties up to now clearly. Now we are going to see further other two properties. What are those? We'll observe here now. Now it is the identity. So in this first one, additive identity. Here we see that only one rational number. Let A be a rational number. The condition is that such that A plus 0 is equal 0 plus A is equal to A. So just I'll make it clear for this. Such that A plus 0 is equal 0 plus A is equal to A. Then 0 is the additive identity of rational numbers. So, see here, additive identity, the rule here, let A be an rational number such that A plus 0 is equal 0 plus A is equal to A. Then 0, as we are adding the 0 itself here, we are getting the same rational number. Then 0 is called the additive identity of the rational numbers. And if we go for the multiplicative identity, similarly, change the plus symbol into multiplication.